What if you could add enterprise-grade authentication to your FastMCP server with just environment variables? While Scalekit handles all the OAuth 2.1 heavy lifting, including JWT validation and client registration. We'll show exactly how to configure this using required environment variables like FastMCP server auth and FastMCP server auth Scalekit settings. The example demonstrates a fully protected server where Scalekit automatically validates tokens against your resource server, enforces HTTPS in production, and supports inspection of user claims, all while keeping your business logic clean and separate from auth complexity. From FastMCP, import FastMCP. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals my Scalekit protected server. At MCP, tool. Def protected action, SDR. A tool that requires authentication. Return, access granted via Scalekit. This demonstrates the environment-driven authentication pattern using FastMCP's Scalekit integration, where all security configuration is externalized through required environment variables. The code shows how to create a protected RPC server that delegates authentication entirely to Scalekit's OAuth 2.1 provider, with the server name used for monitoring in Scalekit's dashboard. What makes this distinctive is the complete separation of authentication logic from business code, achieved through explicit provider selection via FastMCP server auth and related configuration variables. The pattern works by establishing a declarative security contract between your server and Scalekit through mandatory environment variables including the provider class, environment URL, resource ID, and server URL, which must match the JWT's Auth claim. Scalekit handles all identity provider integrations, SAML, OIDC, OAuth 2, ADFS, Azure AD, Google Workspace, and performs comprehensive JWT validation, keys, RS-256 signatures, issuer, audience, expiry before requests reach your tools. This follows the principle of configuration over code for security, where changing providers or settings requires no code modifications, only environment updates. This approach solves the problem of implementing enterprise-grade authentication without embedding identity logic in your application, while supporting production requirements like HTTPS enforcement and detailed auth logging. The trade-off is the operational dependency on properly configured environment variables and Scalekit's availability, but you gain automatic security updates, compliance features, and the ability to inspect tokens within tools for user context. The pattern is ideal when you need SSO, MFA, and audit capabilities without writing authentication code, though it requires careful environment management to prevent silent misconfigurations. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tools with Scalekit authentication. Configuration requires specific environment variables. FastMCP server auth must be set to Scalekit, plus provider-specific variables for the Scalekit environment URL, client ID, resource ID, and MCP URL, which must match the JWT's Auth claim. The Scalekit provider handles full JWT validation, including RS-256 signatures, issuer, audience, and expiry checks, while supporting enterprise identity providers like SAML, OIDC, OAuth 2, and Azure AD. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals my Scalekit protected server. This initializes FastMCP with Scalekit as the OAuth 2.1 provider, requiring specific environment variables. FastMCP server auth equals Scalekit plus Scalekit-specific configs for environment URL, client ID, resource ID, and MCP URL, matching the JWT's Auth claim. The server name appears in Scalekit's monitoring dashboard, while Scalekit handles all JWT validation, RS-256, issuer, audience, expiry, and supports enterprise identity providers like SAML, OIDC, and Azure AD.
At MCP, tool. Def Protected Action, SDR. A tool that requires authentication.
The @MCP tool decorator marks this function as a protected endpoint, requiring Scalekit authentication via environment-driven configuration. FastMCP validates JWTs against Scalekit's provider, checking RS-256 signatures, issuer claims, audience matching via MCP URL, and token expiry, all without hard-coded credentials. Critical environment variables must be set. FastMCP server auth equals Scalekit, plus provider-specific IDs and URLs for Scalekit integration. HTTPS is mandatory in production, and the server name appears in Scalekit's monitoring dashboard. Scalekit supports enterprise identity providers, SAML, OIDC, OAuth 2, ADFS, Azure AD with MFA and SSO, while detailed auth logs aid debugging.
Return, access granted via Scalekit.
This return statement delivers the authenticated response payload to AI callers after Scalekit validates the JWT. The string confirms successful authorization through Scalekit's enterprise-grade auth layer, which requires explicit configuration via FastMCP server auth equals Scalekit and related environment variables including FastMCP server auth Scalekit RMCP URL, matching the JWT's odd claim. Scalekit handles all token validation, RS-256 signatures, issuer, expiry, and supports SSO providers like Azure AD and Google Workspace, while HTTPS becomes mandatory in production. The server name parameter links to Scalekit's monitoring dashboard for observability. Scalekit FastMCP Authentication. The @MCP tool decorator exposes Python functions as secure endpoints, while Scalekit validates tokens through explicit environment configuration. FastMCP server auth must be set to enable this provider. All 5 Scalekit environment variables, FastMCP server auth Scalekit are required, and MCP URL must exactly match the JWT's odd claim. HTTPS becomes mandatory in production, yet the server remains stateless. Authentication lives in the token, not the session.
The endpoint that never sees a password enforces every password.